Welcome everybody to day 17 of Foundation Programming. Thank you guys for showing up. I'm sure we'll start getting some more people coming in. Last night we were going through common problem solving patterns. We finished talking about our what you call it, our multiple pointers. After the class ended, we had a good half-hour conversation answering some questions. Today we're going to pick off from where we left off, which is unique values out pi. Unique values is going to implement the exact same, I'm pretty sure the exact same method as the multiple pointers, right? So there's going to be some more practice from yesterday. And we're going to start off today's lesson with that, as discussed yesterday. And then once unique values is complete, we'll do a code along with that and move on to our next pattern for the evening. All right. So go ahead and open up your VS Code, open up the repository, and get your unique values.py file ready to go. Let me go ahead and pull it up. My keyboard always gives me issues. Give me a second. All right. I should be sharing my screen. All right, so under lesson 11, go ahead and open up your unique values.py. Let's check that out. We're going to have to create a function called count unique values, which is going to accept a sorted list, right? Here's the keyword, right? The sorted list. And it counts the unique values in the list. So only values that appear once, right? There can be negative or positive numbers in your list, but it will always be sorted. Notice here that here we have +1. On the other example, we start at -2. We only want to count the number the first time it appears. Notice that the first example here, we have 1 and 2 as being our unique values. There's two of them. Even though 1 is repeated 5 different times, we'll only count it once. And then we have the number 2. So 2 unique values in the example, therefore it returns 2 to us. The next one, the result is 7. While looking through the lists, we have 1, 2, 3, they come out once, and then 4 comes out 3 times, but we're only going to count it for one of its appearances. So this makes our count to 4. We get to 7, it appears twice, but we only count it once, so it makes our count to 5. 12 appears twice, we only count it once, makes our count to 6. And then 13 appears once, so bringing our count to 7. All right, so pretty much just going to the list that is sorted, finding a number, only counting it one time, and then ignoring it every single time that we encountered it again. All right. Use the multiple pointers lesson that we had yesterday to get yourself your answer today. So we'll take 15 minutes doing this, and then we'll do a talk through code along. So give that a try. I'm
Can't hear you, Roger.
Okay, there you go. I'm sorry. I guess I was muted. I'm assuming you guys can see my code because I got thumbs up from Owens. But we're looking here at our unique values.py. It's going to be an empty file. And we already talked about what this agreement was asking from us. So we're going to go ahead and define our function, which will be called count unique values, right? And it's supposed to accept a sorted list. I'm going to use R for array to represent that list. And it should count the unique values within this list. Notice that on line 8 of my README, I do have a list that has nothing in it. All right, so I do have to take into account this edge case. So what I'm going to do is I'm going to ask if not R, right? And what if not R is going to do is going to check whether this list is empty or not. And we can kind of see that functionality too. We can print out R, or say else print R. Well, actually, let's change out the functionality for the first check. We'll say list is empty, right? Let's see how this works so you guys can understand the way that it's interacting with our list. We can go ahead and let's use this demo that we have, right? We have our different lists. Notice that when we run it, it's going to print out the list if it has it, but if it's empty, it's also going to say list is empty, right? So the first time we're saying if not R, print list empty. It doesn't print it, right? But we do print out none. Let's return R, not print out R. Because this second print here is giving us none because nothing's being returned. We have some weird functionality here where none's being printed out. Let's print it again. Clear it. I'll use what you guys are supposed to be doing too, which is printing out with the console. See the unique values. Python unique values.py. Right. So notice that the first time we run it, it's gonna say, hey, is R empty or not? By asking it if not R, it's gonna check if it's empty. If it's empty, it's supposed to print out list is empty. Notice that it doesn't do that, right? It returns to us R because there's something in there. Second time, same concept. There is something within this list, so it returns the list. Same thing with the third one. And the fourth one, it gives me two things back. One is list is empty, which is supposed to be the print statement if the array has nothing in it. And in this situation, it doesn't have anything in it. It also says none, because when it got to this line of code, it prints out list is empty. It never returns anything. So when I try to print out again here, I print out the function, it's going to print out none because nothing was ever returned from the function, which is why none is being given right now. But that if not R is going to tell us whether a list is empty or not. So it's a very nice thing to use. So now you know that functionality. So if not R, I want to return 0, right? And that's coming here from the demo. We can see here that if it's empty, it should return 0. Return 0. Else, actually, I don't want to return anything. I just want to check if it's empty or not. Now, if it's not empty, then we want to go ahead and move forward with our functionality, right, of our function. So we're going to say if length of array, we're going to check if it's 1. All right, if there's only one item in this list, then there's no point of having to do some left and right pointer because that one number should be just one unique value, right? It's not going to have multiple of them. So we can return 1. Why? Because there's only one number in there, one unique value. Therefore, our answer is only one number, right? So we took care of whether it's empty, whether there's only one unique value, and now we can do the functionality to check if there's multiple. So if it's multiple, we're going to go ahead and create our left and right pointers. So we can use left and right, just like we did yesterday, or we can do something a little bit more familiar to you guys so you guys don't keep confused. We can say left is equal to 0, which is going to be our first pointer, and right is equal to 1. All right, it's going to be our second pointer. We're going to want to check these numbers from left to right, not from the back and the front like we did yesterday. All right, yesterday we were trying to check combinations. Today we're just trying to check every value that moves forward. They're all sorted, right? So I know if the number 2 appears, if it's going to be another 2, it's going to be right after it. It's not going to be at the end of the list. So there's no reason to put a pointer at the end of the list because it's probably not going to catch it because it's not there, right? So ideally, we want to have our 2 pointers at the very start because once again, the keyword was sorted, right? It's a sorted list. So any duplicates of these values are going to be back to back, right? So we set up our left and our right pointer, which is going to be at index 0 and index 1. Next, I'm going to say while right does not equal the length of the array. right? So what that's checking is my far right pointer. Once it reaches the end of my array, right? Once it equals the last index, I want to come back, right, and finish what I'm doing. I no longer need to keep looping through because that means I've already looped through everything that there has to be looped through, right? So while right does not equal the length of the array. Notice I say the length of the array, not length of the array minus one, right? Because I want to check that last index. It's once I've gone out of the index range that I need to stop this while loop, right? So we don't use -1 or -1. We check the entirety of this list. Now, while we're doing this while loop, I'm going to check if array left does not equal array index right, then what does that mean, guys? Let's think about it. Let's look at the example here on line 2. What's array index left? Well, at this very start, it's going to be at index 0, so it's going to equal to whatever 1 is here on line 17. What is array right? Well, it's going to be index 1, so it's going to grab the 2. It's going to check if array left, which is 1, does not equal array right. That means there's no duplicate values because it's a sorted list, right? We mentioned if it's going to be duplicates of values in a sorted list, they're going to be back to back. So if it's not back to back, that means these two are different and it's no longer going to be duplicates of that number. So if the left and the right do not equal each other, that means we have a unique value. So we need to keep track of that. So up here, I'm gonna add another value. Unique is equal to 1. Why am I saying 1, guys? Because the very first one is going to be unique, right? We've encountered at least one number. Even if there's 7 of that exact same number, that's at least one unique value, right? So we need to start it at 1. And the second number is different. That means unique has to go to 2. So we're going to say unique plus equals 1. Right, now that we've established that the first number and the second number are unique, right? We've increased our count. Now we can go ahead and keep moving forward with our count, right? We're going to shift our pointers. Well, where do we want to shift it? Well, I already checked the first number. So now I want to compare the second number to whatever the third number is going to be. So the left number needs to become the right. The left is going to equal right, right? Now, the next thing is checking if array left is equal to array right, right? And we'll probably have to do something like elif r left equal to r right. Actually, we might have to do this. We might just have to change the right value. Right might have to increase by 1, right?
Roger,
Yes.
why wouldn't they both have to increase if they are the index values? If you've already checked 2 of
Yes,
them.
that's what I'm getting at right now. It looks like I might have to go ahead and increase the right as well. Because the left should now be what right used to be, but right has to move to side as well. And this should do this until the very end. Let's see what this gives us. Let's return unique at the very end of this. Return unique.
What I mean is that wouldn't the left skip 2? Because I mean, it would skip 1, right?
No,
And that's because the second index was already checked. So now it should be at 3 and 4, right?
no,
Okay.
right? Because we compared the second value to the first value. We can't just skip those and go to 3 and 4 because what did we not compare 2 and 3?
Wait a minute. So okay, so on the first thing, they are assigned to 0 and 1. So we
Correct.
check 0 and 1.
Correct.
And then
right?
it go 2, 3, or no?
Well, let's take it, let's break it down a little bit, right? So
Okay.
index 0 is going to be 1. Index 1 is the number 2. We've compared these two, right? We've established that these are not the same. So at a bare minimum, the first number is unique. So we increase our count to 1, right? Or I guess to 2, because we've already established we have two unique values here. 1 and 2 are not the same, so therefore we have two unique values. So now we have to shift our pointers to the right side. Well, left is going to become whatever right is. So left is now 2, right? And now we have to compare the value 2 to this value here that's next in line,
I got
right?
it. It's like doing monkey bars.
Kind of, yeah. Yeah, okay. That's the one way of putting it, monkey force. Yeah. We have to compare the next one. So we can't just skip 2 and 3 and go straight to 3 and 4 because we never compare the 3 to the 2. Make sense? We have
Yes.
to compare them in order: 1 to 2, 2 to 3, 3 to 4, 4 to 4, and so on and so forth.
Got it.
Okay,
Thank
so
you.
no problem. So we've established what happens if they are not the same, right? Uh, Notice here that even though I increase my left, my right, uh, what's not happening? My unique is not increasing. I'm not finishing this. I'm getting I'm getting no return. What we didn't take into account was what happens if they are the same. If they are the same, then what needs to happen is right needs to shift over. Right needs to shift over. Right, and we see that here. Uh, let's say we start the for loop or the while loop. We see, hey, is left equal to right? Well, it is. So that means right needs to scoot over and make some room for me, right? So then right will become the next one. So now left is index 0 and right is index 2. Hey, is left and right not the same? No, they're not the same. They are the same, right? 1 and 1. Index 0 is the same as index 2, which is also 1. So that means right needs to scoot over again. And he has to keep doing that until I find a number that does not equal the same, making it unique. And it won't find one until it reaches the very end. At that point, then the unique goes up to 1. The left is equal to right. So now the left pointer moves up all the way over here because now left is equal to right. Right? And now we check, hey, is array left and array right equal the same? Yes, they are, because they're both pointing to the same number. Let's increase our right by 2, or sorry, not by 2, by 1. And it is no longer within the range of this index. So therefore, the while loop stops. Why is this? It's not. What's going on here? There we go. We get 2, 7, 4, and 0. Once again, I'm gonna break it down. Right. Let's use the line 2 as an example. When we first start off, left is equal to index 0 and right is equal to index 1. So therefore, we get these two values right here, right? We started at unique is equal to 1 because at the bare minimum, even if both index 0 and index 1 are the same number, that's one unique value. So unique has to start at 1. But we've already encountered that. We get to the while loop. We're going to say, well, right does not equal the length of 2. That means once right is out of the index range, then we're going to stop the while loop. So because it's not, we're going to start it. We're going to say, hey, is left equal to right? No, it is not. These are both unique. That means we're going to increase our count by 1. And then we're going to change whatever left is. Left used to be index 0 and right used to be index 1. But now that we're done checking these, left is going to equal to whatever right is equal to. So now both pointers, both left and right, are now pointing to index 1 right here. Right? And then I'm going to go get to this next else if check. It's going to say, hey, does left and right equal the same? Yes, they do. So let's move the right by 1. So now right becomes 3, but left is still 2. All right, so now our left and right pointers are pointing to 2 different values. The while loop goes back around and it does the same check again. It finds out that 2 and 3 do not equal the same, therefore our unique count goes up. We shift our left to whatever right is equal to. It's 3 in this situation. We go to the next check. We see that they're both pointing to the exact same thing, so we need to shift our right, so our right becomes 4. And it just does that over and over and over and over again until it finishes the while loop, until right is out of the index range. And while we do that, we are counting how many unique values we have. You see here we get 2740, the exact same representation of what these answers should be. 2740. Too easy, guys? Understanding now?
Yeah, I have a quick question,
Yes.
more related to just the broad general scheme of things. So, like, I used a hash map. I did, like, if kind of like what we did in the first problem, I think it was called frequency or something. And if, like, that number wasn't in the hash map, I added it. If it was, then I added 1 to the value. Like, if I were to do this, say, in an interview, like, it's still big O of N, or no,
It is.
big O of N, but they say they were looking for like your solution. Like, how would that play out like in an interview? Would they, is that like, I know that it's not a point system, but is that like, okay, this guy just relies on hash maps rather than actually thinking of how to solve this problem most efficiently? Or is it still, since it's still big O of N, he's good?
They're both big old, and you might encounter that. It's typically around the context that you might encounter them to ask you for a different solution is usually because your solution is trash. You probably did some subpar solution and it's not too efficient. And they probably know that there's probably a better way of doing it. And they're gonna ask you, okay, well, what's the time complexity on your solution? And then you will tell them, hopefully you know, right? They're like, okay, so he knows what he's talking about, so he knows what his code is doing and how long it's taking. And then they're gonna ask you, is there a more efficient way of doing this? And if so, what way do you think we can make use of it, right? How can we do this in a much better way? Right? And then you would give them one of these solutions, either this one or the one that you just talked about, right? Typically, if it's the same time complexity, they're not going to ask you to show you a different method of doing it. It's usually because your method was too complex, right? You probably did O of n squared, right? Which is not ideal. So, in that scenario, we're like, okay, well, let's see. In my solution, the time complexity is O of n squared. I'm using a nested for loop. Therefore, I'm increasing the time complexity. If I wanted to, maybe increase this better, we can create a hash map, right? You talk about your method. You can code along too, kind of show them a little bit that you know what you're talking about. I can create here a dictionary where within this dictionary, the keys will be the unique values that I'm finding, right? And then once I'm done with my looping through and checking how many times it's appeared, what I can do is I can just count how many times how long my list is, therefore letting me know how many unique values I've encountered. Uh, because they're not nested loops, even though they're both these methods, I'm using 2 different loops, they're not nested. It will increase my time complexity to O of n. So it's still an ideal method. Right, you just explain that to them. You can kind of show them as well, like how that code would look like. Uh, Usually they're not gonna make you rewrite your entire code there, because some of these interviews are not that long. But yeah, that's how,
Thank
that's
you.
how that scenario will go. No problem. Anybody else? I had this
Can you
one
scroll
interview.
up? Can you
Yes,
scroll up, please?
yes, I can. Let me lower this. I had this one interview, guys. It was for uh, a renewable energy company, and I was interviewing for a DevOps position. Oh, as I was, this isn't the same interview. It's a different interview. I was interviewing for an apprenticeship with this one company. And the apprenticeship was a year long, right? Uh, the interview process was very annoying because it took forever for me to land an interview and then to hear back from it. But the interview was an hour long. And the first 30 minutes was all knowledge based, right? They asked me about everything, like what are the fundamentals of like object-oriented programming, like how would you run this script, or if you wanted to do this, how would you do it, yada yada. When it got to the actual coding portion, they gave me a link. They're like, go ahead and open up this link. It's gonna take you to a problem. It was some random problem in some freaking bootleg third-party leak code website. Never seen it or used it. That should have been my first red flag. They gave me this problem. And they're like, they asked me to solve it. They gave me 20 minutes. Uh, I I shit you not, I spent 20 minutes trying to figure out what this problem was asking from me. This problem was so confusing. Um, I just could not wrap my head around what the problem was asking. And it got to a point where, like, at first, the interviewer was kind of getting annoyed with me, trying to explain to me what the problem was asking from me. Uh, by the last 5 minutes, even he got confused with the problem, which was my only saving grace to the interview. That the senior software developer, the one that gave me this challenge, like ended up reading the problem. He's like, huh, I guess I see where you're getting at. And then he's like trying to figure out, like, okay, how would we do this? So then we're both sitting there, like, just trying to figure out what the question was. That was like my only saving grace. That the like it wasn't just me. I wasn't dumb. It just the problem was worded in such a weird way that and I was telling them, if it was asking me to do this, I could do it in this manner. But the what it's asking from me seems like why would I do that? It sounds like inefficient, and I was like trying to explain that to him. And he's like, okay, I see your points, yada yada. I ended up not getting the job, not because of the coding challenge, but they said I was too experienced for this apprenticeship. They're like, uh, you are, what's the word they use? I'm overqualified for the apprenticeship, like the fact that I was an instructor, I've done all these projects, and I had my own website, yada yada. Like you're kind of overqualified. Like, we might give you an offer later on if it ever comes up that we might need our own instructor, or if we need some like some third party to do a website for us, we could hire you. But for the apprenticeship, you're a little overqualified. But the more story wasn't that part. It was just the fact that the interview process and how that goes and how what they ask from you. It's not always about solving the problem. Sometimes they want you to solve it. Sometimes they want to hear you just know, like if you're knowledgeable about what you are doing. A lot of these interviews, they're gonna ask, like they're expecting you to talk through your thought process as you're doing it. And if you can't talk through that process, that's the probably the deal breaker, because that means you probably don't know what you're talking about, or you're not experienced enough where you can talk through the process as you code. So you're probably too focused and you're tunneled in what you're trying to do to stay focused. Um, but yeah, I thought it was funny. All right, we're gonna go ahead and move forward with our next one. Hold on, give me a second. I am sending a message to my wife. So that was unique values, guys. Now looking at our, where's that? Okay, going back to our slides. So we just took care of unique values. Hopefully that was some kind of a learning experience for you guys. That was a really interesting problem. Next is going to be our sliding window pattern, right? So it's going to be a different pattern. It's kind of similar to multi-pointers, but it's a little bit different. Same, but different, right? Let's look at it. So this pattern involves creating a window, right, which can either be a list or a number from one position to another, right? So that's kind of what I meant by like kind of similar. You have a pointer that points to a start and an end point, right? But usually you create a list, almost like slicing, right? Depending on a certain condition, the window either increases or closes. You either increase the range of how many numbers you're capturing, right? You're increasing that list, or you're decreasing it, or you're even moving it through you're moving it through your list. All right, so very useful for keeping track of a subset of data in a list or string, right? I'm gonna show you the not so great solution so you guys have an idea of how that works. Do not look at the great solution because I don't want you guys to cheat. But this is the example. We have this function called max sublist sum. we have a list of integers and then we have a number, right? And this number is what we're going to be using to reach our goal, right? We're going to say if number is greater than the length of list. So here they do a check, right? Essentially what this function, the intent of this function is to find out what is the greatest sublist that we can find within here with the biggest sum, right? So if we had a list of different numbers, how many consecutive numbers back to back can we get while grabbing the max sum of all those numbers, right? So obviously, if we're trying to grab 8 different numbers, but the length of the list is only 6, then right off the bat, we should return none. We create a variable called here total, and that keeps track, obviously, of our sum. And then we say for I in range, they start looping through the overall big list, the integer list that we have. Notice that the length of it is the actual range of it, but then they also subtract the number plus 1. So let's if the list is 8 integers long, but we're looking for 3 numbers, then we're gonna subtract those 3 numbers and we're gonna add 1. And what this is gonna do is gonna essentially grab, I wish I could explain it to you guys to show you. It might be better if we kind of code along with this one. What do you guys think? Does it look too confusing?
Could you maybe go to the README and then kind of talk through what our code's supposed to do on one of the test cases?
Sure. Let's look at the README. So we have to write a function called max sublist sum, which accepts a list of positive integers, right? This is our list, right? And a number called num, which is 2. The function should calculate the maximum sum of n consecutive elements in the list. N is going to be the num, right? N is equal to whatever the num is being passed in, that second argument. And we see here that the answer is supposed to be 10. So somewhere along this line, there's 2 numbers added up together will give you the sum of 10, right? Consecutive, right? Keep that in mind, consecutive. So let's say we start a window. Our window is 2 integers long because that's the n we were given. So our window needs to start from index 0 to index 1, giving us these 2 numbers, right? And then once we get our sliding window, we're going to add up everything in that sublist, right? This is our sublist. What's the max? It's 3. So we're going to go ahead and check our total. Hey, is 3 greater than our current total? If so, I want to change what my total is to my new total, which will be 3, right? Because we have found that the max sum that we've encountered so far with 2 consecutive numbers is 3. Next, we're going to slide our window to the right. Right, we're going to change the index for our start and end point of that sliding window, of that sublist. The new start point of the sublist is going to be index 1, which is going to give us this number. And the end point of that new sublist needs to end right here between 5 and 2, therefore grabbing us these 2 numbers. Then we add these together. 5 and 2 gives us 7. What was our total before? It was 3, right? Our 3 came from adding 2 and 1. But now that we added 2 and 5, this is a new higher sum that we've encountered. So now we're going to check, hey, is our current total, which is 3, is that greater than 7? No, it's not. So therefore, we need to update what total is, right? Because now we have a much greater number, which is 7. Once we calculate these 2 numbers right here, 2 and 5, we're going to shift the window to the right. Now we have 5 and 2. It's the same thing. Then we shift over to the right again. We have 2 and 8. We add these together, it gives us 10, right? Our last total was 7. But now these new combination of 2 numbers is going to be 10, which is higher than our current total. So now we override that total. We're going to say, hey, total is now going to equal to whatever 2 plus 8 is equal to. Right, so now our max total is 10. That's the highest number we counted it. We shift over to the right. Now we have 8 and 1. That gives us 9. It is not greater than total. We go to the right again. We have 1, 5. It gives us 6. Once again, that's not greater than total. We've now finally reached the end of the list. We've looped through every consecutive number in here. The maximum we got was 10, so we returned 10. Same thing here, right? Here, the number that we're being given is 4. So we need to find the max sum of 4 consecutive numbers. So our num is going to give us a sub list that starts here from 0 to index 3, right? We're going to add these up. 1 plus 2 is 3, plus 5 is 8, plus 2 is 10. So our current total right now, starting off, should be 10. We're going to shift to right once. Our new numbers are from 2 to 1. Add these up. We have 2 plus 2 plus 1 is 5, plus this 5 is 10, plus 8 is 18. Did I do that wrong? Oh, I did do that wrong. I'm so sorry. It's supposed to be 4 numbers. So we have to get 2 to 8, not 2 to 1. 2 plus 2 is 4, plus 5 is 9, plus 8 is 17, right? That is higher than the numbers that we got when we added these up, right? This gave us 10, but this is giving us 17. So now we have to update what total is, right? Which is not 17. Then we shift to right again. Now we have these 4 numbers. And we do that over and over again. So looking back at that README of what it was doing, it started, where did it start the for loop at? It got the length of the list, right? It got the length of the list. Let's kind of look at this list real quick, right? We're going to use our examples, right? What's the length of this list right here? 1, 2, 3, 4, 5, 6, 7, right? So this is 7. 7 minus the num that we were being passed in, which is 2, is going to give us 5. Plus 1 is going to equal 6, right? So this right here is returning 6, right? So we're saying for I in range of 6. Why are we saying 6? Well, because our initial window starts here. That's going to be the first loop, the second loop, the third loop, the fourth loop, the fifth loop, and then the sixth loop, right? We'll only have to loop 6 times to make it all the way through this list. And they were able to calculate that by grabbing the length of the list, subtracting how big the sublist is supposed to be, and then increasing it by 1 to compensate for the index. That's what this is saying. Does that make sense to you guys now? Granted, this is the not so great solution, right? So obviously it's a little confusing. So you might want to do there's probably a better way of doing this, right? So this starts a loop. They have temporary equals 0. They start a nested for loop where they grab index 0 to whatever num is, which is going to be 2. So this is going to loop through the first sub numbers within that sub list. They add every single one of those integers together and add it to temporary. They compare what our current total used to be with what our new total is. If our new total is greater than our old total, then we change it. So everything that I explained earlier of how it's supposed to work with that sliding window, that's what that code is doing. But time is 6:27, guys. Go ahead and take a 10-minute break. Return at 6:37. Upon returning, we're gonna go ahead and start. I'll give you guys 15 minutes to give this a try. I'll see you guys then. All right, guys, let's go ahead and come back to it. 15 minutes has elapsed, and I hope you guys were all able to go break. We are not gonna go into the sliding window. Let me set it up. Okay. So I'm gonna share my screen. All right, so we had a pretty thorough discussion about the intent of the sliding window and kind of how it would work. But now let's actually see it in action, right? So we are going to go ahead and copy and paste these code here already so we can kind of get ready for us. And then we're going to define our functions. Define max sub list sum. And we see here it's supposed to take in an array. So we're going to say array, and then we'll say n just for now. Right now, we have to write a function that should be able to take in this list and then find the maximum of the sub array that matches the length of whatever n is being passed in here, right? So first and foremost, we're gonna check just like that kind of not so good problem check. We're gonna see if the length of the list is less than the number. So we're gonna say if length of list of, or what do we call it? Array. If the length of the array is less than n, then I want to return none, right? And we see that here as well on line 9 on the example. We see an empty array, and the number they're being passed in is 4. So they're asking for, hey, find the maximum of our sublist with a length of 4. But we can't have that because we have nothing in here. So that would take care of that edge case. Next, we're gonna get the max sum right now. So we can say total, or we can just say max sum. Right, we need the max sum, and I want the max sum of the very first items that come up to the range of whatever n is, right? So I'm gonna say that I want the sum of array, and then when I get up to whatever n is, right? This is a for loop, guys. Right? It's gonna go through and add stuff together, so it's gonna be a for loop, right? O of n right here. It's gonna be O of n, right? O of n to whatever this is, but I'm not doing nested, so it should be fine. So right off the bat, my time complexity already went to O of n. And then I'm going to say for I in range. Oh, I can't type. For I in range, and the range I'm going to do is going to be it's going to start at whatever n is, right? Whatever num is, and then moving forward, right? Everything after whatever my start number is. So if I'm looking for a sublist of 2, right? I want to get from index here and onward, right? So it should only loop up to the start of this and then the end of this. So it should be the start of n and then up to the length, right? The length of whatever array is. So what did I just do? I pretty much just did exactly what this says, just a little bit backwards, a little bit more human readable, right? Like I told you, there is a better way of doing it, and this is the way of doing it. All right, this is gonna be the start. The start's gonna be at n. Let's say n. We see here that it's supposed to be 2. So if we use it as an index as a start point, it's gonna start us up here at index 2, which is 5, which is perfect because it's right after the 2 numbers that we need to get, right? And then up to the length of whatever the list is. This length is 7. So if you guys don't remember, the range is going to be up to, but not including that second number. So we don't have to calculate for any kind of index or whatever. All right. So let's gonna start a for loop. And we're gonna say in this for loop, we're gonna say current sum. Right. Current sum is gonna be the current sum that we are currently getting, which is in our for loop. And I'm gonna say that this current sum is gonna equal to whatever my what should I make this list to be? I'm gonna say it's gonna be current sum is equal to. Okay, I see how I can do this. I'm gonna create a different variable here. I'm gonna say current sum is equal to max sum. That's going to allow me to kind of call on the current sum that hasn't been instantiated yet without manipulating my old max sum. I might change it later, but I'll keep it like that for now. I'll say that current sum is equal to whatever current sum is minus what the last number is and then the new number. And notice I'm gonna do that. I'm gonna say array. I'm gonna say I minus n. Array minus name plus array I. So what is it saying? Well, let's say if we're using this example, right? The first two. The current sum right now is the max sum, which is 3, right? But I want to get a new sum. That new sum needs to be whatever the next number is going to be, right? The sum of 2 and 5. So I'm gonna override that what the current sum was with what the old sum was. So this will be 3, right? I'm going to subtract I minus num. What is I right now? I is 5, right? Because where do we start our for loop? At whatever n took us. 2 is n. 2 is index 2. So n ended up being 5, right? By saying I, which is 5, minus whatever 2 is, right? It's going to take me back 2 numbers. And it'll give me this. It'll give me index 0, right? To give me index 0. So I'm going to subtract the first index within that sublist. And then I'm going to add the next number, which is 5. So this little line right here, what I just did, it dropped one number and added a new number into what current sum is now in. So all within this line, I was able to change the sum to whatever the new list is going to be by dropping the second list here, or the second item in this list. Does that make sense to you guys? Right? Current sum is 3, right? This is 3. I subtract the first number within that sum and added the next number to that new sum, therefore giving me the sum of these two numbers. Right? So in sense, it shifted the sums of the subarray and I can move it forward. Right? Without manipulating what my max sum was, right? Because I created that second variable. And now I can say the max sum is going to equal to whatever the max is between max sum and current sum. Right? It's going to take what my initial max sum was, what my new current sum is, being passed in here as arguments, and this max method is going to grab these two. It's going to say, which one's greater? Well, whatever one's greater, I'm going to save it to the max sum variable, reassigning it, right?
Doesn't max loop through those two elements, or does it not? It's just two.
That's a good question. I would say it's not O of n because it's not growing exponentially. It's a fixed number. It's only going to be 2 of these. Does that make sense? It's one or the other.
Yeah. Would
If
it be
it
more
was,
efficient just to say if put an if statement if current sum is greater than max sum?
yes, we can do exactly that. If max sum is, let's say if current sum is greater than max sum is equal to current sum. Right? And if not, well, what happens? Nothing happened. Max sum stays the same. Because obviously current sum wasn't worth anything. Because it wasn't big enough. So yeah, you can do that. And at the end of it, we're going to return max sum. Let's see how this works. We see 10, 17, 6, 13, and then none. That's how that sliding window works. Where's my sliding window, Roger? It's right here. Right. This is the sliding window itself. I save the start and the end point of a list. Therefore, give me 2 ranges, right? I created initially here by grabbing that sub array by using the length of what n is. And all I'm doing right here is by moving that sliding window by dropping the first number and adding the next number afterwards. Right. So it gets instantiated here, it gets shifted here.
Another question for your max sum equals sum array colon n is the colon n, is that just a method that we can use, or?
Yeah, so this comes from the Python crash course, which if I recall, you probably weren't present, so it looks a little foreign, right? So this is how you slice arrays. So how do we access things in arrays? we know that we use bracket notation, and we can say array index 0, array index 1, right? You also have the option to use a start and an endpoint by separating them with a colon. So we can say, I want to grab everything from index 1 up to index 5, right? This will grab whatever's at index 1, and it's going to go up to index 5, but it's not going to grab whatever's at index 5. It's only going to go up to it, right? Now, what happens if you don't add a variable to the left or to the right of that colon? It's going to grab the default is going to be the start of it, right? I can do the same thing over here. I can put n here. What's the default going to be for the right side?
The end of the array.
The
correct.
end of the array, correct. If you don't give it a parameter or an argument here on the left and the right side of the colon, it's going to immediately by default grab the last or the end, depending on what side it is. So that's what that's doing, right? The left and right tell you where do I want to start and end this index range. It's like using the range function. You know how we give the range a start and end point of how we want to range through? Same concept, but within those brackets, we use colons.
Thank you.
No problem.
Explain.
Who else? Why did I add that second variable current sum? Again, I wanted to be able to keep my old sum, right? I grabbed the initial max sum of the first of where my sliding window starts, right? But then I want to create a temporary variable that I can manipulate it. So I save max sum to current sum. That way I can actually manipulate this one. And then I manipulate it, and then I just compare and contrast which one's greater. Okay, well, obviously, current sum will be greater than max sum, so I'm gonna change it, right? That's the reason of adding this second variable. That way I can keep the old variable and still be able to compare and contrast, right? And then how this works, guys, it just goes back to how we started this for loop, right? We started this for loop, the range at whatever n was, right? N is gonna be 2, right? That means we want to get 2 indexes worth of a subarray, right? So that means we obviously don't need to worry about this. Once we get the sum of these, then there's no point of starting a for loop and trying to grab the sum because we already do that here. So our for loop needs to start after those 2, right? Which is why we use n as a start point for the range. And then we can also use that to kind of get the to drop the first number, because obviously since n is a start point, what does I become when it first starts doing the for loop? I becomes whatever the start point was of this for loop, once again being 2, so I is essentially equal to 2, right? We subtract that n, that start point, to grab the very start of the subarray, and that gives us the first part of that subarray, right? What is I? I is equal to 2, which when we start the for loop, we have already came to the understanding that the start of the for loop needs to be the number after the end of the subarray. So I know that this will automatically grab me a new number that's to the right of the end of that subarray, right? Hopefully that makes some sense. If not, just rewatch the video. All right, we're gonna go ahead and move forward, guys. Good stuff. So that was the sliding window. Here is a much better solution. I don't think this is similar to mine. Oh, it is similar to mine. We have 2 variables here. We have max sum and temporary sum, right? Both start at 0. They once again check the length between the overall array and then what the desired subarray we're looking for. If it doesn't match, we turn none. We loop through for I in range of num, essentially doing what I did, getting like the sum, but they manually coded in here. They loop through how many times b and how big that subarray needs to be. If it's 2, it's going to grab the first 2 indexes, add it to max sum. Notice they create that temporary sum and save the max sum in there. That way they can manipulate the temporary sum without overriding the main big concept of what max sum should be, right? The top level. But we have this temporary sum value that we can manipulate. They loop through starting from num, right, to the end of that list. Notice how they are subtracting, right, the first value of that subarray from the temporary sum and then adding the last value. And then they grab right here, whichever one's bigger. All right, next, there's not much into this one, but we kind of already discussed about it a little bit. Right, so this is the divide and conquer method. So this pattern involves dividing a data set into smaller chunks and then repeating a process with a subset of data. This is a unordered list of random numbers. They split the array in two. Right, after they split in two, they keep doing that until they're only left with one number. And once they get to the last number, they're essentially checking, hey, is 38 greater than 27? If not, switch them. And they do that to every small subarray they create until they essentially sort it. There's no example for this one, and there's no actual problem to it. I'll see if I can find something to kind of help you guys do that one. This is a sorting technique. In the main classwork. All right, moving on. So that concluded lesson 11, guys. Let's go ahead and move down to the next class, which is searching, sorting, and recursion. All right, the last two lessons that we actually have, guys, is just these two right here. Searching, sorting, and recursion. We don't actually have any real work when it comes to challenges and speedrun, because we still have some lecture to do. So searching, sorting, and recursion. Let's go ahead and open that up. We're going to start this off. The first one we're going to talk about is going to be searching a list, right? So we've already seen that we can search a list using for loops, right? So searching a list for a particular item is a very common computational task. The simplest approach to searching a list for an item is called linear search, right? Linear search. That means in line from the very top or from the very front to the very back, one by one, right? Until we find what we're looking for. Time complexity of a linear searching or looping through a list is O of n. N being the number of steps it has to take. That grows linearly with how many items are in that list, right? So the more items there's in there, the more steps we have to do. They grow linearly together because obviously for each new item there's another item we have to loop through, right? We see that here we have a list and we have a target that we're looking for. We loop through the list by using for I in range and then using the length of however long that list is. And then we compare every I that we find, right? Every index using a list index of I. We compare that to the target to see if it's equals to what we're looking for. Return yes if the target's in the list. Return no if the target's not in this list. Note index and the in operator that is used on list are both linear searches under a hood in the Python, right? Not to get confused with dictionaries where we use the in method. That's not O of n because that uses the hash of the key, right? Where here, even if you use the dot index method to try to find something, right? Or if you use the in operator on the list, it's gonna have to linearly search every single item one by one until it finds it. Binary search, a more efficient algorithm for searching a list, but only if it's sorted. You saw that with my little drawing that I showed you guys from like 1 through 16, and we cut up those numbers in half, yada yada, until we found what we're looking for. It worked because it was sorted, right? It worked because it was sorted, because we can compare, like, hey, is this number within this range? Nope, that means we don't need this half. We're gonna work with this other half. This type of algorithm focuses on dividing a data set into smaller chunks and then repeating the process with a subset of data. Once again, back to that image I showed you guys where I drew for y'all. This algorithm can tremendously decrease time complexity. Binary search pseudocode. This function will accept a sorted list in a value. You create a left pointer at the start of the list and a right pointer at the end of the list. I showed you guys right, left, and right. Is it within these ranges? While the left pointer comes before the right pointer, create a pointer in the middle, right? That's you dividing your list in half. and then you compare it. If you find the value you want, return the index. If the value is too small, move the left pointer. If the value is too big, move the right pointer. Right? If you never find the value, return -1. Student practice, binary search .py. We are now on lesson 12. So we are about to hard code what that drawing did for you guys. I don't think there should be too much explaining for this one because I already showed you a drawing demo. So you're gonna create a function called binary search, which accepts a sorted list. Sorted, right? It should return the index at which value exists, otherwise return -1. So essentially, you're gonna have to grab this list, create a start point, an end point, and then a middle point, right? And then you're gonna use that middle point and you're gonna compare it to the target you're looking for, right? Let's say the midpoint of this list, let's just I don't know where it's at. Let's say it's 40. Right, let's say that's your your middle pointer. Your target is 10. You're gonna compare it. Hey, is my middle pointer greater or lower than 10? Well, obviously it's greater, right? That means everything that comes after my middle pointer, absolutely useless, right? Everything that comes after 40 is gonna be cut off. So what I'm gonna do is gonna move my right pointer, which is initially at the end of my list. I'm going to move that to wherever 40 was, or at least the number before it, right? So now my right pointer is 37. My left pointer is still 5 at the beginning. And now I have to move my middle pointer to whatever my new middle is. Let's say it's 18, right? Is 18 greater than 10 or less than 10? It's greater. That means everything between 18 and 37, which was my new endpoint, is now useless. I have to move my end pointer to below 18, which is going to be 14. So my start point has yet to move. My endpoint is moved to 14 now, and now I need a new midpoint, which is going to be 10. Hey, is 10 equal to 10? Yes, it is. Therefore, I found this in 3 steps, guys. Instead of taking what could have been forever, right, which would be equivalent to whatever the length of the list is, it took me 3 steps. Granted, 10 is the third item here in this list, so it would have taken me 3 steps anyways, but we talk about worst case scenarios, right? Let's say we were looking for like 95. It would have taken me forever. Or 98, right? If it was 98, my halfway point would be 40. I would have to cut all this out. That'll be 1 step. This is my new list. 86 will be my midpoint. 98 still greater. I'll have to cut everything out before 86. That's 2 steps. Brings me down to 4. 98. Right? It'll probably take me 2 or 3 steps. But if I searched it linearly with a for loop, it'd be 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth steps until I found 98. And that's why binary search is very strong, right? Using this method. So go ahead, code it out, guys. I'll give you guys 15 minutes. And then after the 15 minutes, go on your last break. And then we will do it talk to the walkthrough. Time is 7:18. Go on break around 7:37. And I will see you guys at 7:47. I think that's good math. I don't know. 7:47, we'll come back. I won't be in my camera. I gotta go get the groceries from the car. My wife just got here, so I'll be back. All right, time's up. Let's get to it, guys. So we were talking about the binary search lesson. Go ahead and share my screen. You guys should all be looking at my empty VS Code right now. So we talked about it earlier, so let's get straight into it, guys. I'm going ahead and copy and paste these print statements for our tests. My keyboard's waking up. There we go. All right, go ahead, make some lines here. We're going to find our function and call it binary search, right? Binary search. And this function is going to take in a sorted list. And it's supposed to have a value, and it should return the index at which the value exists. Otherwise, return 1, right? it states here that we should use the binary search algorithm. Now, how do we actually do that? Well, it's very similar to the multiple pointers, but instead of 2 pointers, we're using 3, right? So we're going to create a left and right pointer. I'm gonna do it my way this time by doing left comma right is equal to 0 comma. And then I want the end of the list, right? So I'm gonna say length sorted list, and then -1 to grab the last index, right? This is the same thing as declaring 2 different variables, guys, both left and right. I'm just doing it one liner. That way you guys can learn this too. You guys will like it or not.
Can you zoom in 2 clicks, please?
Yes, I can. Let me go ahead and zoom in for you. There we go. You guys should be able to see that a little bit better. All right. So after I create my left and right pointer, I'm gonna create my my mid pointer just yet. I'm gonna go ahead and instantiate my while loop. So it's gonna be while left is less than or equal to right. Notice I'm putting equal to, right? Because due to the nature of having odd and even numbers, sometimes when we cut stuff in half, we might not have like an even cut. We might end up having both the left and right pointer equaling each other, right? So we're gonna do less than or equal to, and we're essentially comparing our left and right to know once we've reached the end, right? Once again, we are starting from the back and the front, and then we are gonna create a mid pointer and then cut stuff in half depending on what the mid pointer is compared to the value one, right? So after I start this while loop, I am going to declare a variable called mid. This is gonna be my mid variable. And it's something as simple as left plus right divided by 2. Why left plus right? Well, let's use the example here for a reason. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 numbers in this list, right? What is index right? It is 19, right? Because this right here, when we get the length, it returns 20 -1 gives us 19, right? This is index 19. And then 0. How do we get the halfway point? Well, 19 plus 0 is 19 divided by 2 gives you 8, right? What if our mid pointer switches later on, and instead of it being 0, now it goes to wherever the 9 is at. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Let's say one of these numbers becomes a new left pointer. When we get our mid pointer, it'll be 9 plus 18, right? Will end up being 27 divided by 2 will give us like 14, I want to say 14.5, something like that. But we're gonna floor it, so it should give us like 14, something like that. And where is it at? Well, this is 9, 10, 11, 12, 13, 14. It actually gives us the halfway point, right? So by adding the left and right pointers and dividing it, notice it's the floor divide, not just regular divide, it's floor division. Then it will give us the halfway point every single time between the left and the right pointer, right? So we get the mid pointer in that exact fashion, adding the left and right pointers and then divide it by 2. After we get the mid pointer, now we want to do some comparing of values. We're gonna say if sorted list, we're gonna grab the mid pointer, right? If sorted list is equal to the value, so right off the bat, if it's equal to it, then we don't gotta do anything else, boys. We just gotta return it. Return mid, right? That means we found what we're looking for. But that's not a perfect world, so obviously we're gonna have to take into account if it doesn't happen. So we're gonna say elif sorted list mid less than value. So in the event that mid is less than value, that means that our midpoint is too low, right? So everything before mid is useless, right? So we need to switch whatever left pointer is. That means if our mid pointer here is supposed to be 40, right? And our value is 84, that means 40 is less than 84, the value we're looking for. right? Obviously, everything that comes before it, we'll never have to touch it again because it's always going to be greater. So we need to move our left pointer, which is currently at 5, and move it up to where we are currently at. So we are going to say left is equal to mid plus 1. Why mid plus 1? Well, we already compared the mid in value. Obviously, mid is lower than the value. So not only do we not need mid, we should probably move it to the side of mid, right? So we get the next number after mid. So we have to do mid plus 1. Right? Now, if it's not equal to value, it is not less than value, then obviously it has to be greater. If it is greater, we're going to do the exact opposite as what we did to left. We're going to do it on the right side. We're going to say mid minus 1, right? That means the right needs to move over to the left, right? And past whatever our midpoint was. And at the very end, if this keeps running to the point where left and right are now touching, right? They're past each other. Obviously, we have not found the answer yet because we would have returned with our mid answer. So we need to return with -1, meaning we never found it. Am I recording? Oh, I hope I'm recording. I am.
You are.
Okay, now we run these guys, and we see here 2, -6. I'm sorry, not -6. 16 and -1. And that matches exactly what our test cases are asking for. 2, 16, and -1. All right. That is a successful binary search assignment. Any questions, guys?
I haven't had time to think about this much, but will it catch the very first or the very last, if that is the number, the target number?
Yeah, it will. Let's think about it, right? We have left and we have right. We're looking for 99. Let's say our midpoint is 37. Obviously, 99 is going to be bigger. So left gets moved to 40. So now our left pointer is 40. Our right pointer is still 99. Our mid pointer is going to be somewhere 84 or 86. Let's just say 84 for the sake of it, right? 84 is our mid pointer. Is 99 our value we're looking for greater than 84? Correct. This is our going to be our left pointer now. This is our right pointer. It keeps doing this until we get for something like this. Left pointer is 98, right pointer is 99. We add both indexes, this is 19 and 18. That gives us what? 37? 19, 18, 37, right? Divide that by 2, it gives you 15, 16, 17, 18. I would say 18 as the index, something like that. I don't remember. Point is, it'll get to this point, right? Mid will end up being some weird number like 18 and a half, whatever. It'll go down to floor, right? It'll be floored. So 18 will end up being one or the other. The midpoint will end up being either the same as the left or the same as the right, right? Because it's going to get to a weird point where we only have 2 numbers to divide between. Obviously, when we try to find which one's the middle between this, it's going to go to the floor. So it'll probably become 98. We're going to compare mid to what the value is. Mid is 98. Our value is 99. Obviously, does not equal the same. So what happens? We move our left pointer, right, to whatever mid was, +1. So now both left and right pointers are both the same number, 99. Right, both the same. Right, and then how do we get the middle? We add left and right pointers, which are both index 19, which ends up giving you 38 divided by 2. Both left, right, and mid will end up pointing to the same pointer at the very end. There's only one last item.
Okay, I didn't put or equal to, so mine is wrong. Mine would not have caught the first or the last. I get why you put equal to them. Okay, thank you.
No problem. Good stuff. Anybody else?
Yes, so even though I got the concept, I had used slicing instead, and I had made an infinite loop because I just could not figure out how to how to decide and reach the end of a list. So, but this here answered it by you just using the index values itself. So,
Okay. Well, I'm glad you understand it. Now, I'm curious, Mike. I'm just curious out of your own thought process. Why'd you use a well, what'd you say you use? You said
slicing.
why'd you get why'd you slice your list?
So what I would so I did the binary search in a section, right? So in a sense, it's almost like the guess number game that I saw in the book that you recommended, because I had started reading it last night, the Gronk's algorithm thing.
Mm-hmm.
And so when it was talking about dividing it, and so what I did was look at the value, slice it in half. What's the number that I get? Is it less or more? Either shift left or shift right. So the group would be from the left all the way up to the value where that index was at.
Okay.
Yeah.
I see.
Yeah.
All right. Anybody else have any more questions, guys? Right on. Let's go ahead and move on. We're on our last hour of tonight. That concluded binary search. Binary search example. Man, they had one here. Okay. First and last index, right? We declared something very similar to this. They did well. First is less than or equal to last. Then they created their middle, right? This is I want to say it's probably verbatim by what I got. What's the big O of binary search, guys? Who can guess?
Would it be O of log n? If not, it'd be big O of n.
O log of n. This is I hate this graph for a specific reason. O log of n is not the same as O1. I do not like how they're putting it here the same thing. This is very misleading. Also, the way that O log of n works is that it grows, it gets faster. It becomes more efficient the more stuff there is that it's searching through. And this graph doesn't do any justice, unfortunately. But it is O log of n. Good guess. Let's talk about sorting, guys. So sorting list is another very common computational task, right? I'm sure you guys probably have already encountered it doing LeetCode and stuff. It tells you to sort a list, right? You probably encounter it even during your coding challenges to get into the program. There are many different ways to sort things, and different techniques have their own advantages and disadvantages. And the next slide, we'll see a list of different algorithms that are used to sort, their names, as well as their time and space complexity. Notice that some have, depending on what it is, some have good time complexity, some are bad. It's up to you guys which one you guys use, but they all have their pros and their cons. Let's go on. You guys can look at the slides on your own if you guys like to compare contrast, but it's not a big thing. We are going to cover bubble sort. All right, so we will not learn all these sorting algorithms because that's beyond the scope of this class, but we will learn a very popular one called bubble sort in order to get a feel for how they work. Many sorting algorithms involve some kind of swapping numbers to put them in order. This is a very important thing to understand in programming. All right, bubble sort gets named from the highest numbers in the list bubbling to the top, swapping places with adjacent values until the list reaches some kind of order. And here is the very quick example, right? We have this right here, which essentially takes in a list and two variables, index 1 and index 2. notice the way that they swap things. This is the two ways that you can swap variables in your code. This is a much cooler looking version, but you can obviously do this one. Notice here that they get index 1 and index 2 of whatever is within this list is equal to index 2, index 1. Here, index 1 is first, and then index 2 is second. Notice that on the right side, when they assign it, they reassign it, where index 2 is now first, and index 1 is now second. Right? So whatever is assigned to those indexes, they're swapping their assignments. And then they return the list. Here is the more common way that you guys can probably do yourselves. The less sexy way, where they create a temporary variable here so they can assign whatever value index 1 has. After that, they assign the value of whatever index 2 has into index 1. And then they assign the to index 2 the old index 1, right? Therefore, just doing a swap. They're swapping the values. Both of these will do the exact same thing. One just looks sexier than the other, right? So use whatever one you want. Bubble sort pseudocode, right? So essentially the way that bubble sort works, right? You are going to iterate from the back of the list towards the front, right? You start at the back of the list towards the front. And then you have to start an inner loop. What is an inner loop, guys?
A for loop, like an in. It's nested.
It's a nested loop, yeah, unfortunately. It's a nested loop. I think it shows it here too. Bubble sort average is O of n square. I don't think I've done it ever at O of n, but I'm sure people know how to do it. All right, so you start an inner loop with a variable named j from the beginning until I negative 1. If list j is greater than list j plus 1, swap those two values, return the sorted list. This is your pseudocode. What's pseudocode, guys? Do you guys know what pseudocode is? We've been seeing this term a lot.
It's almost
Yes,
like
you-
just talking through it in English, writing it
Yeah,
out.
that's exactly what it is, right? You're just talking it out. It's pseudocode is very common seen here when people are coding. Instead of writing straight up, like straight up code, sometimes it's good to just write pseudocode. And I've done it before. It's like, okay, like when you first encounter a problem, right? And you know, it's still a lot to unwrap. It's telling you different things. You're taking different variables, different values. You gotta do this, gotta do that. Taking into account the fact that you might have this and yada yada. It can sometimes be a lot. So instead of just jumping straight into just code, where you might just get tunnel vision and forget about second, third order effects and and whatnot, we write pseudocode, right? And I can use this as an example, right? Imagine this does not exist here, right? Imagine everything from line 5 to 15 does not exist. And this is the first time I'm reading this example, this problem. I can be seeing here that I have to take in a sorted list and the value, and it should return the index at which the value exists. Otherwise, yada yada. I come to the conclusion I'm probably gonna have to do some kind of like binary search. So I know I probably have to maybe create a start and end point. Maybe start a while loop, right? So you go through it and you talk the steps out. Start a while loop until my points meet. Identify a midpoint. Compare midpoint to value, and then after you get your your rough sketch in, you kind of go through back through your coding, and then you actually start doing right. All right, what's the first step I had to do? Create start and endpoint. All right, yep, I remember that. Left is equal to whatever, and then you go to the next part, and you slowly kind of build your code without getting overwhelmed with information where you might lose sight of what the true goal of the problem is, right? So that's pseudocode. You kind of talk through the problem itself. I just want to make sure you guys knew that, so in case you guys hear that term, I don't want to have people here just kind of listening to me and not understanding. All right, so let's check out bubble sort. It's gonna be the last timer for the day, guys. We're gonna do bubble sort, and then we're gonna do a talk through, walkthrough, and then we'll leave the remainder of time for any kind of questions. And that'll be it for today. So within lesson 12, open up bubble sorts. Okay. So you're gonna write a function called bubble sort that takes in an unordered list, guys, an unordered. All right. Do not try to do some weird stuff like binary searching here or adding those pointers like you did earlier. This is a completely different algorithm that we're doing, right? Try to use this method, all right? Don't go adding hashes and whatnot, making hash tables, Owen. All right, the point is to learn these algorithms, okay? So you're gonna take in an unordered list of integers. We see that here, right? And you need to return them sorted. No, do not type in dot sort, right? Do not manually use the sort method. That's defeats the purpose, right? Notice here, this is the unordered version of this list. You're gonna go back and sort it, right? You're gonna have to write the code to sort it. Use the examples that I showed you guys here on these slides about how to swap different variables. You're gonna have to swap variables, right? Your code will probably have to have a nested loop. As you get better, you might find a better way of doing it. But for now, just go with the nested loop. I understand, right? It's not the most ideal, but there is gonna be times that you're gonna have to do nested loops. Let me just get that out of the way. And I have to say that because every time I do this class, every time we talk about big O notation and we talk about time complexity, when we start talking about O of n, O of n square, people suddenly become super scared on using nested loops. Nested loops are okay. All right, I want to make sure I say that out loud. Nested loops are okay. It's fine if you have a nested loop. It's not the end of the world. There's times where the only thing you can do at that moment is probably use a nested loop, right? Everyone uses nested loops at a certain point. The issue comes when you start doing nested amongst nested loops. When it becomes cubic, all right, you got an issue, buddy. Get out. All right, that's different. You can have a nested loop. It's okay, and then go back, maybe find a much better way, refactor code to kind of make it all end at a minimum, right? But nested loops, you will see them a lot throughout your career. It happens. It's okay. Do not fear them. I have to get a disclaimer out because students were getting just afraid of nested loops and they were getting stuck and not knowing where to go or how to do things because they don't know a more efficient way of doing it yet because they haven't gotten to that level. And the only thing they know how to do at that moment is maybe use a nested loop, and they just ended up hitting a wall, right? And then they get frustrated. So it's okay about using a nested loop, right? Don't fear it. Give bubble sort a try. Time is 8:11. You guys have until 8:30, right? You have 19 minutes. 8:30. After 8:30, we're gonna get down to it, do a talk through, walkthrough, and that'll be the end of the day. 8:30, guys. Give it a try. All right, let's get it. Go ahead and get down to it. Let me share my screen. Once again, this is the last assignment, guys. Thank you guys for sticking to it today. Are you guys seeing my VS Code? Right on.
Yes, sir.
Good stuff. Good stuff. All right, so I'm gonna go ahead and copy the test cases. Get this out of the way. And then I'm gonna define my function called bubble sort. Booble sort. Booble sort that takes in an unordered list of integers. I'm just gonna call this array. All right, so this function should be able to take in a unordered list of integers and return to the user a list that's sorted. So I'm gonna have to sort through every single item in here. All right, so I'm gonna go ahead. I'm just gonna I'll do some pseudocode. So I'm gonna want to sort or loop through the list once from start to finish, right? And as I go through it, I also have to loop a loop a second time, essentially inner loop, and compare essentially I'm gonna say this is I and compare I to what's gonna be J for a second loop, right? The first loop I will call it I, the second loop I'm gonna call it J. So essentially I need to loop through. Actually, let's use X and Y. I feel like X and Y is easier to remember. I think. All right, the first outer loop, I'm gonna call it X. And then within that inner loop, as I loop through X, I need to compare it to my second inner loop, which is gonna be the Y, right? This should be another variable. For the first time I'm gonna loop through at the start. The second loop should be able to grab the next item and compare it. Hey, is 5 greater than 3? If so, I need to switch these, right? Which essentially then it will look like this. 3, 5. Right? And then I continue to compare it in that manner. And as I loop through, I need to check compare X and Y greater or less than, right? Essentially, this is going to be greater because I'm trying to find the greatest one and put it to the far end. If X is greater than Y. And then if it's greater, switch X and Y. So let's start that out. So I'm gonna say for X in range of a range of what? Well, I want to loop through the entire list. So I can just say length of array, right? For X in range in whatever the length of the array is. Why it's giving me an issue. Length of array. Oh, I'm done. Intention. All right, for X in range of whatever array is. And then after that, I need to do an inner loop and say for Y in range, but where do I want to start this? I need to start this at let's see. Where should I start this? Should I start the second one? I'm gonna start at 0. For Y in range is 0, and then I want to go up to whatever the length is of my array. Like I say, length array. -1. But I need to compensate for the fact that I am moving numbers, right? I am moving X, right? At some point, when I am moving these integers, X will end up being at the very end of my list, right? For example, let's say X is 10. If I end up moving it at some point, the big numbers are going to be the very end. So therefore, I shouldn't be looping all the way to it after a number has been moved because it's already been accounted for. So I'm going to say minus whatever X is. And then -1 for the index. So why minus X? Well, because if X starts off at the beginning, right? Let's say it's 0, or I'm sorry, let's say it's 1. All right, because I believe it's gonna start at 1. Let me confirm that. I'm pretty sure it starts at 1. It's been a while since I've done this. They should be for I in range of let's say R print I. This object is separated. Oh, my bad. Let's go ahead and do bubble sorts, and let's give it 6, whatever. Yeah, it starts at 1. Okay, now it starts at 0. Uh-oh. Starts at 0. So it starts at 0. It's gonna start at 0. It's gonna grab index 0, and then we start for Y in range is 0. And we start at 0, so we're gonna compare the first one and the last one. I guess we can start at 1. So we will start this at 1. For Y in range of 1 to whatever the length is of my list, what's gonna happen is at some point, right? Let's say here, I'm gonna start with X, right? The first time this loop starts, it's gonna start at 5, right? It's gonna grab this one. That's gonna be X. And then we're gonna start that inner loop. And Y should start at 1. And then we're gonna compare, right? We are currently holding on to 5 and 3, and we have to compare if array X, right, or 5, is greater than or array Y. And if so, we should do array X, comma, array Y is equal to array Y, comma, array X, right? That should be the intent here to switch them. So what's gonna happen after that, it's gonna get here, 5 is obviously gonna be greater than our Y. So it's gonna switch, right? 5 will become 3 will be here and 5 will be here. And then it's gonna go back into this loop. We're still within the inner loop, right? The outer loop has not continued. So X is still 5. And because X is still 5, we are going to continue. We've already covered 1, so it should go to 2. So now we're comparing 5 and 10, right? 5 and 10. It's going to check is 5 greater than 10. It's not. So this is going to stay the same. We are now, and this is going to be 3, right? Y will be 3. So it's going to be grabbing the 5 and the Y, right? Because X is still 5, right? Oh, is it? No, it's not. Because we're doing in range of. We're still working with 0. We're still working with 0. For X in range of this, it starts at 0, so this is 0. For Y in range of 1, so this is 1. So we're still working with 0. So even though we switch these, X is still working with index 0. So still comparing what is at index 0, and we just switched it, right? So now it's comparing 3 and 10. That doesn't switch. It compares 3 and 6. That doesn't switch. And then it's going to compare 3 and 1. And that should switch, right? This will end up being 1. And 3 will end up taking this spot right here. Right? Finally, it finishes its first loop. This, which started at 0, is now going to be 1. Right? So now we're on 1. So it's going to compare whatever is at index 1. This needs to reset somewhere else. It's going to start at index 1. Well, we don't want it to start at index 1. Okay, here's the issue, right? The next time this restarts, X already moved to index 1. But what just happened? When we go into this inner loop, we are a number ahead, but there's a number behind us that we are no longer counting anymore. So range is gonna have to be 0. Range is gonna have to start at 0. That way, even though there's some numbers that end up being moved to the left, it doesn't mean that those numbers can't move up any further, right? Because there might be some numbers further down the list that are going to be lower than these numbers, so they might have to move again. So the inner while loop or the inner for loop needs to restart at 0. So once the outer for loop moves on to 1 and the inner for loop starts running again, this inner for loop needs to go out to the exterior. Right? This needs to go to the exterior, and we will compare index 1, or I guess array X, which is 1, right? What is array Y, which is reset at 0, which is greater? Is 5. Is X greater than Y? Well, yes. It is. But what's the issue here?
Wouldn't you want to just loop from the next highest index?
Yeah.
So like for
So
Y
this,
in range, it should be X plus 1, correct?
it should be actually Y plus 1. So this should be Y plus 1. And then same thing up here. It should be within the next one. Or no, you are right. I think we're going to be X plus 1. So it should be X plus 1, X plus 1, and then X plus 1 here as well. So every single time it's just grabbing the next index. Okay. I think we're onto something here. I'm doing this from the top of my head right now, just walking through it and talking to you guys my thought process. Right? So back to this. It would get whatever 5 is at, and it's checking the next one. So if we go back here, remove this, right? If we restart this, for X in range of whatever length of array is, this will be start at 0. This will start at 0. It's going to compare it. Obviously, they're the same, so nothing happens here. Y is now going to be 1, while X is still stays at 0. It's going to compare. Hey, is X greater than X plus 1? Well, yes, it is. So we're going to switch these. So this should be 5 and 1. Wait, did I do something wrong here? Did I never reset this? I'm sorry. This should be 5, 3, and 1. My bad. I was manipulating the test cases, but I never switched them back. So it checks between 5 and 3. Obviously, 5 is greater. So it's going to switch these out. This becomes 3. This becomes 5. Cool. Goes back up here. We cover the 0. We move on to the 1. So it's going to compare whatever X is. So it's not going to be 3 again. It's going to compare compares that. Obviously, it's not greater than that. So it's going to move on to the next one. Then we go to 2. It's going to compare 3 and 10. Obviously, it's not greater than that. It's going to move on to 3. Not greater than 3. It moves on to 1. 3 is greater than 1. So now we will switch these. So now 1 takes this spot. 3 will take this spot. And finally, this will reset. And we will move on to index 1 in the outer loop. So now we're working on this. It's going to check, hey, it's 5 greater than whatever is afterwards. No, it is not. So move on to the next one. Oh, not here. Move on to the next check. Right. And what happened here? Well, we reduced the length of X, right? So we were initially doing the length array minus X, which was 0 at the time because we started at 0. But because we went to the next iteration, this is now gonna grab the length of the array minus X. So it's no longer gonna go all the way up to 3. It's gonna go only up to 6, right? Because X changed. Therefore, this is a 1. So we're subtracting the length of what we are covering the second time we loop through, right? So when it checks 5 and 10, 5 is not greater. It's gonna check 5 and 6. It is greater, but it never gets to 3. Because of that, I believe. Let's see this in real time. Let's print this out. Let's print this out. Let's run it. Do I have to return anything? I do. I need to return. If I ever find that I need to return, actually, just return the array because it's gonna loop through everything. Switch it. 1, 5, 6, 3, 10. There's something wrong here. I never switched this out. 5, 3, 10, 6, and 1. Let's remove these. These and this. For X in range in whatever the array is. And we run it and we get 3, 5, 6, and 10. Is it because I'm doing length of array? If I do n equals length of array and switch this to n. No. N minus whatever that is, minus 1.
What happens if you do the -1 on line 5? I'm just curious.
I see what I'm doing wrong. Okay, I'm sorry. I am switching the X, but I need to switch Y. I need to switch Y because we're working in the inner loop, but why would I be switching the outer loop when it needs to be the inner loop? That's being switched out. There we go. I knew there was something wrong. I was getting some weird functionality because I wasn't supposed to be switching out the outer loop. I need to be switching the current number I'm working with in the inner loop. And let's see that. Right. So I start X, this starts at 0. Right. And let me add some notes here. They start at 0, and so does this. Right. This starts at 0 as well. We're getting the right answer now. So when this runs, it's going to grab index 0. And then the inner loop is going to grab, it's going to start at index 0 as well. So when we say array y greater than a y plus 1, it's checking the outer loop. The only thing it's doing, this outer loop is only doing one thing for us. One thing. And the only thing it's doing is keeping track of the overall loop or how many turns this has to loop through. Right? That's all this outer loop is doing. I wouldn't even look at this right now. If anything, I would ignore this outer loop. Right? Everything above this should be ignored. All this is tracking is how many times we have to actually loop through depending on how many numbers we have. Right? The real functionality, the real meat and potatoes is right here. Right? Because that's what Y is doing. Y starts at 0, right? So Y is checking index 0, index 0 plus 1. That's what this is doing. Y plus 1. It's checking if within this list, if whatever is at index 0 and index 0 plus 1, which one's greater? If 5 is greater, then we're going to switch these up. So this should become 3, and this should become 5. Right? That switches up. That was the first time. We are now at index 1. So I no longer have to check this. I am now here. Is index 1, right? That's what this is now. The greater than index 1 plus 1, which is 2. No, it is not. So it moves on. And it's going to keep doing that, right? We are now index 2. We're working on with these two numbers. It is obviously greater. So we are going to shift these two numbers. This will be now 6, and this will be now be 10. Right? Then it compares 10 and 1. Obviously, it's greater. It shifts them. So now we have 1 and 10. All right. That's the first iteration we did. This now goes into the next iteration we have to do. So the outer loop is just checking how many times we have to loop through the entire array before this gets solved. And we're only going to loop through it a maximum of whatever the length of this array is, because that's mathematically that's all we're working with. Right? So this is our current working one. Now we reset our inner loop. Our inner loop goes back to 0. Is 0 greater than 0 plus 1? Right? We're talking about indexes right now. It's not. Right? So then we go to 1 in the range. Is 1 greater than 5? It's not. We go to 2. Is 2 greater than 1? Yes, it is. This switches. 1, 6. Right? Then we compare 6 and 10. It's not. That was the second time the outer loop has ran. We reset, and it keeps doing that until we reach this outcome. It'll switch to 1 and 5. Nothing else is out of order. So it's going to keep running through. And this moves on. Until finally, the very last time, switches 1 and 3. Does that make sense, guys? Of how that worked? Notice that every time that we loop through once, we are shifting one of these the Y range. We are bringing it down. Well, why? Because every time I loop through, one number will eventually reach the end. Right? If 10 is down here, if 10 is the greatest number, let's say it's 10, 9, 8, 7. The first time this loops through, whatever the greatest number is, that number will make it to the end right off the bat. Every single time we loop through the outer loop, one number will make it to the very back, because that's just the nature of things, right? It's obviously going to be greater than every other number before it. So without fail, every single time this outer loop runs, there will be the max number will be at the very end. Therefore, we no longer have to check that number. So we decrease the range that our inner loop is doing by 1, because it's no longer needed for us to go that far. Right? Make sense, guys?
Yes.
Do I have any questions? I'm sorry that took a little too long. I'll kind of like dissecting it, trying to figure it out. If you guys couldn't solve it, or if you guys were having issues, hopefully just watching that, like walk through, and just listening to a thought process, maybe open up your eyes a little bit, or lit up a light bulb. But who has any questions right now?
On line 7, can you explain the n minus x minus 1?
Yes. So, this outer loop is going to take care of the overall amount of times we have to loop through our list. We only have to loop through it how many times? Well, that's going to depend how big this array is, right? So because this array is only 5 numbers, every time that we do one full loop, one number will always end up being sorted at the very end without fail, right? Without fail. Doesn't matter what number it is, whatever the max number is, it'll always be to the very end. That means at a maximum, we will not make more rotations than the length of our list. So right off the bat, we know the outer loop, it has to be whatever the length of our list is, which is why we do the length of the array is equal to n, and that's going to be the first outer loop. That keeps track of the maximum loops we will have to do overall. But the inside loop is different. The inside loop is where we actually do the manipulating, right? We need to be able to loop every single time. We have to start from the beginning to the end. But not every single time that we do a full loop do we have to loop through the entirety, right? We've already established, right, that the outer loop every single time we do a full rotation, one number will always end up being sorted and ending up at the very end. No longer needed to be touched, right? Because, for example, looking at this list right here, the first time this loop runs, 101 is gonna end up at the very end. This will end up looking like this. First go ahead, first rotation in the outer loop. That means there is no other number that can be greater than 101. So we no longer have to do a range of this entire list. We can now just remove this number from the equation. That's what that is doing, right? We are looping from 0 to the length of a list, but we are going to track X to get rid of how many numbers have been sorted already. The first time is not going to be an issue. Why? Well, because it's the first time we loop through. That means X is equal to 0. That means we have yet to sort anything yet. So when it gets to line 7, it's going to be 0 in range of the length of the list minus 0. So there is not deducting a number from the end of that range. But we are going to deduct 1 to compensate for the index, right? The second time this loops through, that means we've already sorted one number, right? That means this is now going to be in range 1, right? The first time the range method starts, it starts us off at 0 index. The second time it goes, it's going to be at the first index. That also means we've already looped through once through this list. That means that there is probably the highest number is currently sorted at the very end, and it no longer has to be touched. So because this is now 1, we subtract that 1 from the length of the list, no longer needing to touch that far end of that list. To give you a better example, we can see a drawing here, right? This is our list, right? For X in range of N, it's keeping track of the overall times we have to loop through until every number is sorted, right? And then for Y in range, we did in range of 0, comma, N, which is the length of the array, minus X minus 1. Right, this is going to start. Where's X going to start at? The first time this starts, it's going to start at 5. This for loop is going to look like this. It's going to say 0, 1, 2, 3, 4, right? That's how the range works. It's counting down in the whatever the length is. What is the length of the array? I already established that. I created this variable called N. It is equal to the length of the array. There's 5 numbers in here. Therefore, this method returns 5. So N is equal to 5. So when I do for X in range of N, I'm saying for X in range of 5. 0, 1, 2, 3, 4, 5 different numbers, right? Because it starts at index 0. But it does 5 loops. So when X first runs, it's starting off at 0. So it's going to grab us the very first number, right? That's technically what X is, right? It is 0. But 0 is only going to keep track of how many times we have to sort a number. Every time we run this, there's going to be one number that is going to be sorted to the very end. Is 5 greater than 3? Yes, it is, right? So that's going to be moved up to the front. 5 is not greater than 10. So eventually we'll just go to 10. Is 10 greater than 6? Yes, it is. Is 10 greater than 1? Yes, it is. And 10 is going to end up at the very end, therefore sorting it. But we'll get to that, right? So we've already established this outer loop is keeping track of the overall rotations. The for Y in range, right? This right here is going to be the actual meat and potatoes of this sorting. Y it's gonna start at 0, then goes to 1, then 2, then 3, then 4. Right? So the first time this runs, it starts at 0. Right? It's gonna start at 0. And we're checking. Right? If you remember our code, what did our code say? We're checking if array index y is greater than array index y plus 1. So we're saying, hey, the first time this inner loop runs is 0, right? Whatever is in index 0 greater than index 0 plus 1, which is essentially 1, right? It's checking, is 5 greater than 3? Yes, it is. So it's going to switch 3 and 5, right? This for loop goes from 0 to 1. We're now checking whatever is at index 1 and comparing it to index 1 plus 1. Is 5 greater than 10? No, it is not. So we do not switch these. Y now becomes 2. Hey, is index 2 greater than index 2 plus 1? 10 and 6. Yes, it is. So we're going to switch these up. Two now becomes 3. Hey, is index 3 greater than index 3 plus 1? Yes, it is. And it does that, right? Now, what just happened here? What happened is we have yet, X has yet to move, guys. X has yet to move. X is still 0, right? This is the first rotation. Within that first rotation, what just happened? The greatest number has been sorted at the very end. So what does that mean? The next time that the outer for loop runs, X is going to become 1. But that also means that the greatest number is now at the very end. So we no longer need to check between the second to last number and the last number. Why? Because we just sorted it. So that means, right, we no longer need that last number. And how do we calculate for that? Notice the n minus x minus 1. Who was the one that asked that question? Was it Daryl?
Yeah, it was me.
That's how that works. The first time we ran this loop, x was equal to 0, right? So when we did n minus 0 minus 1, it didn't make a difference. But now that we are running this loop a second time, x is now equal to 1. So when it grabs the length of the list, which is saved into 5, it is into n, right? N is equal to 5. We are subtracting whatever x is. X is 1. So essentially, this is going to run from range of 0 to 5 minus 1, right? Minus 1 for the index, which will give us a max of this. It will not loop through the very last index no more, because we've calculated for the fact that we've already sorted it, right? The second time this runs, this 6 will end up being sorted as well. So this will probably look something very similar to this. So what does that mean, Daryl? That means that the two greatest numbers so far are at the very end. Does that mean I still have to compare these? Do I need to compare the 6 and the 10? I do not. I already know they're in order, right? So when this moves up, n will then move into to being 2, right? Once the loop resets. So when it resets, that inner loop is going to say n minus x, which is equal to 2. That means 5 minus 2 is equal to 3, minus 1 is equal to 2. This loop will only check up to index 2. Therefore, leaving index 3 and 4 outside of the equation because we don't need it anymore. We've already calculated for those. We know they are sorted. Make sense? That's what that x is doing. It's checking. It's ensuring that we are not looping through the very last indexes because we've already calculated for them. Right? They're already sorted.
Yeah, so essentially it's like going backwards.
Kinda, yeah.
Okay.
All right, guys. Time is 9:06. I went over time. I need to go because I also have family. But hopefully that clears up any confusion. I will see you guys tomorrow, possibly for like the last day of class, if I'm being honest with you. We'll try to get through a lot of material tomorrow. If not, it's gonna have to roll over into Friday. But y'all have a good night. I will post this video online. Thank you guys.
Thank you, Roger.